And good morning to everyone. And Ernie, what were we listening to?
Billy Idol.
Billy Idol, Hot in the City. You're wanting warmer weather. Okay. We got the sunshine. Warmer weather maybe to come. At this point, questions from last night. Okay, Kim. This is from the computer, I take it. Okay, do you want to share the problem? And we'll write it in the board. So we're going to go to the board, Ernie. Okay, and the problem.
Okay, solve and check.
Solve and check.
Minus.
Well, let me get the solve and check written down. I'm not done with that. Okay, now you can go with it.
Okay, minus negative 4 1/2.
Is it minus negative 4 1/2?
No, it's
Just the negative.
4 1/2.
Okay, negative 4 1/2.
Plus t equals negative 7 1/5.
1/5 or 1/6?
1/5.
1/5. Okay. Question before we start? Okay, in this process, the only thing that's different is we have fractions instead of whole numbers. Or integers, I should say, because whole numbers would not be negative. So you have some choices here. Technically, if we had decimals that we were working with, I'd probably change everything to minus 4.5 and a negative 7.2 and be done with it. But the intent here is to work with a common denominator. So we're going to add 4 1/2 to both sides to get t by itself. So I'm going to have t is equal to 4 1/2 minus 7 1/5. Now you have a choice here to go ahead and leave them as mixed numbers and find a common denominator, which would give me 5/10, 2/10. But that's a little bit dicey because of the fact that this negative 7 is being taken from a 4, so we're going to have a negative number. So I think I'd be more inclined to simply rewrite this with an improper fraction of 9/2 minus 36/5, changing them to improper fractions. If I do that, then what I need to do is find a common denominator, which is 10. So that is going to change this to 45 over 10. And then I have a negative 72 over 10, which as an intermediate step would be 45 minus 72 over 10. And at that point, we would have, what, a negative 30 or 27? So we have a negative 27 over 10, which you could technically leave. But given that we started with mixed numbers, sort of be inclined to go with that. So I guess I would say negative 2 7/10. Now, we've created a difficulty level here because we're forcing ourselves to go to what? To fractions rather than decimals. So if I right out of the gate up here, and this is looking ahead, and the intent here is to do first whole numbers, then integers, then fractions, and then finally decimals. But I think you have done enough with decimals in the past that you wouldn't see this so terribly difficult if we said negative 4.5 plus t equals negative 7.2. Yes?
Now, what if you wanted to add 7 to get t, add 7 1/5 to the other side?
And then subtract t from both sides?
Yes.
You could, but you're going to have a negative t then, and it's going to work. It's not going to be a problem. I would personally like to keep the coefficient of t positive if I can. So I prefer a positive t than a negative. It will work. And it does get you out of the bind because now you're subtracting in the normal way. You say 7.2 minus 4.5, and that's a little more comfortable, but that will be negative t. But if we do what Michael's suggesting, bring the t over here by subtracting t from both sides, add 7.2 to both sides, and now you get something that is much more familiar on the left side. So you get a 2.7 there without even much thought. That's negative t, but then you need to understand that if the inverse of t is this, then t itself had to be the inverse of 2.7, and we get the same answer. I think that's a heck of a lot easier than this. But the intent is to learn how to handle fractions. So you have to understand the author's intent here, and that is to avoid, in the process, decimals until we have mastered the fractions, which is the same thing I did in Math 10. But Kim, does that answer your question? Any other questions from this set? We're okay there? James? Okay, so number 17 off the computer, which you're going to have to share with me. X plus 19 over 30. 13 over 15. The nice thing about this is the 13 over 15 can be made into a 30th very quickly. Now I'm going to come back to Michael's suggestion. If I were to subtract 13, no, I take that back. I was thinking that was going to be the smaller one. I'll pull back on that because I think I was not anticipating correctly what I would get. Because in this case now, Michael, I think it makes more sense to subtract 19/30ths from both sides because I'm going to get a positive very nicely. So x is going to be 26 minus 19 over 30, intermediate step, so x is going to be 7/30ths. Okay, where is the question, James, if there is one still? Are we okay there? I'll be with you in a minute, Natalie. Okay, whatever happened, you see it now? Oh, we're okay. Okay, Natalie.
Okay, so when because I did mine, when I do that, when I take the 19, from the other side.
So you're asking when I bring the 19/30ths to this side, I subtracted 19/30ths.
You make it a negative, right?
Well, I subtracted 19/30ths, so I'd have 26 over 30 minus 19 over 30.
Because when I did that on mine, because whenever I take it to the other side, I always make it a negative, and then it comes out with a negative answer, which was right. It's negative 7 over 12 whole minus that. You see what I mean? You get what I'm saying?
I hear what you're saying. Let's come back, because you're doing something that I have done most of my life. I'm going to rewrite this as 26/30ths. But I usually think of bringing things across the equal sign in an equation, and it changes it from a positive to a negative. So to that extent, I'm thinking of adding negative 19/13ths to both sides. So in the usual, not trying to save time or save space, where we would add negative 19 over 30 to both sides, you'd have an x plus 0 on the left, which would be x. And then you have a 26 over 30, and you're adding to that negative 19/30ths.
Which in this case, it stays positive. I know that.
Okay, but how did you end up then with the negative 7 by adding negative 19/30ths to both sides?
Okay, let me tell you my problem.
Okay, I'll be with you in a minute, Robert.
It's x plus 5 over 12.
Ah, we're changing the problem.
Yeah.
So x plus 5 over 12,
Equals 1 over 6.
1 over 6.
Okay, so I crossed the 5 to 12 out, and on the
I don't like what you just said. You said cross the 5/12 out. I know, you crossed it out. But I would prefer that you say you added negative 5/12ths to both sides. Thank you. So I added a negative 5/12ths to both sides. And you may say, well, isn't that confusing? Can't you just say negative 5/12ths between each, below each one? I don't object. But this becomes what? As I bring this up here.
it becomes negative 2 over 12.
Whoa. Where did the negative 2 come from?
Okay, because this is how I did it.
Now, hold on. But let me write what I have here.
Okay.
X then is equal to 1/6
Uh-huh.
plus negative 5 over 12, correct?
Yeah.
Now I've got a 1/6. Allow me to get a common denominator, please. How about 2 over 12?
Yeah, but mine is negative.
How did you get the negative? I understand what you're telling me. My question is, how do you defend that you had a negative 2?
Because
Does it make sense now to you that you would get a negative 2? Okay, we have the moment of consultation going on here that happens occasionally. And I'm hoping that it will resolve the issue. Just be patient with us, folks. We're getting there.
okay.
Okay, go ahead, Natalie. Defend your point.
Okay. I can't really defend it. I just did it and I got the right answer.
Well, hold it.
I don't know
Wait
why
a
I
minute.
just
What
did
is
it.
the correct answer supposed to be?
Because the sign with the negative number is bigger? I don't know.
No, but at this point, if I have a 2 over 12 and a negative 5 over 12, my intermediate step would say 2 minus 5 all over 12, would it not?
Yeah.
And that would be negative 3/12?
No, the answer was negative 7 over 12. And the negative sign was in front of the
Okay, now wait a minute. You're saying that when you wrote this problem down here originally,
Yes.
that was the problem originally given by the computer,
Yes.
and it gave you a negative 7 over 12 for a correct answer.
Yes.
Then somebody did a very bad correct answer.
Because to begin with, we had came up with what you came up with. It
That was the correct answer then.
Negative 3 over 12.
But the guess I have is the original problem when it was programmed was probably a negative 1 over 6. And somebody, when they entered the problem into the computer, left the minus sign off, but didn't make the correction. How would you check to see if negative 7 over 12 is a solution? You would have to substitute into here, correct? So you would say negative 7 over 12 plus 5 over 12. That would give you negative 2 over 12, which would be a negative 1/6. And that's not equal to 1/6, so negative 7/12 doesn't work. So what you did originally, when you ended up with negative 3 over 12, which you reduced to negative 1/4, was a perfectly good answer, and then you were encouraged, because that didn't agree with what the computer said, to get creative. I admire your creativity.
That is what she did the first time.
I know, and I'm saying that was the correct answer. So your creativity got you in trouble. You should have, and again, this is easy for me to say, you should have, when you got the answer, been more stubborn about saying, I'm right.
I really had it worked out in my head how it became, because I don't doubt the computer. I don't know.
Oh, but you
Sometimes
should.
there's a few examples.
I know.
Like, oh, okay, I get it now, because it's saying you do the left, you do the right.
Okay, but everything that we did here was valid. But if you are in question, how do you check to see if the answer you have is a valid answer? You substitute in. And if it's not, you write a little note. Okay, I'm going to check this when we get to class because I feel I'm right. And this is a case where there was a time when computers first became used in business, where banks in particular went to using computers. And if you challenged a checkbook reconciliation, you know, where you see how much money you think you have in the bank, and the bank says you have this much and you disagree, and you went to the bank, when the computers were first used, the typical response is, we use computers. We are always right now. And what you soon learned was that they were wrong maybe as often as before. They just got wrong faster. And computers and calculators allow you to make mistakes still, not because the equipment is wrong, but sometimes what we enter data badly, we press keys incorrectly with calculators, programs are written, and the effort here, and I talked with the publishing house yesterday. They were here at the college, and I talked with the rep and expressed my concern that we needed more of the problems from each exercise on my math lab. And that's a work in progress. And so they are paying somebody to enter the problems and write solutions and enter those so you can see them. I think you can easily see why, if maybe there was a negative 1/6 here, it might have been omitted. But on paper, the person's doing a solution for what? For negative 1/6, which would have given the negative 7/12. And they think they're right, and you see it, and you don't get the problem they were doing. So if I were doing that, I very quickly learned when I did my own writing, you can proofread ad nauseum and still make mistakes. I even got to the point where I was proofreading my sentences backwards to make sure I wasn't thinking something that was there that isn't. And I'm finding déjà vu as I try to use the BlackBerry to answer things that are sent to me, I think, and I'm making every effort in the world not to text message in the usual see you later as see you. I spell things out. But I also find that I've got a word in my head that I didn't enter, and so I go back and proofread every message and find out I leave out words that make no sense because I'm so slow thumbing things in. So I'm a lot more tolerant at this point with that experience of saying, okay, you enter things in and you do occasionally miss something. So what I'm suggesting to you, if you think you're right, and say two of you are working together and you say, we're right, then trust yourself. Come back in here and say, boy, this didn't make sense. And then at that point, if you were in error, you're pretty confident of it. But if you still feel that you're pretty right, at least you know what happened. But to creatively make adjustments to try to make something work in the computer just served you badly. And now you have something that you tried that can't logically be explained. It just worked. Okay, so be cautious.
I think we're just stubborn and we just sit there till we...
Yeah, I know. Well, you think that the computer's got the right answer, and you should agree with it. And I think that's a downside. I had a very interesting response sent to me this morning. This was from an algebra class. And it's one of the distance learning classes I have. And the student said, I would really love to have the answers available in the test because when I do all my homework, I check the answers to see if I'm right. And you have that sense of confidence, right? But when you see something that's not there with the answers, your confidence level is very different. And so when you practice for a test, you need to practice without answers being available to deal with that insecurity, if you will. And I understand what's being said. The computer, unfortunately, is providing you the same thing, having the answer in front of you every time, until the computer, in a sense, validates, yes, I'm right. It came up and agreed. You sit there without quite the sense of confidence that you'd like. And so there are a lot of things about the computer that I'm having trouble adjusting to. And Sarah and I have some interesting conversations about pro-computer, not computer. She's not getting the feedback from her students. You're providing me. Now, I know your background, and I'm confident with what you're reacting to, and it's validated very quickly in my mind. Her students are not making those responses. Now, one possibility is you have the class before she does, and if you submit responses, they get cleaned up by the time her class does, or her class just may not be as critical. But we're getting two different sets of experiences. And if I had the luxury of more hours to grade and could give up sleep totally, I probably would not use the computer because I don't like what it is creating in some respects. Now, at the same time, I find an interesting hook on the computer. You spend more time doing homework in the computer than you do if I gave it to you in paper. There's something about it that you're willing to sit there and go through the problems and work more hours. At least that's Sarah's observation of what's happening in her class. Students will spend an enormous amount of time trying to get those 100%. But if I give it to you on paper, you do the problem, you turn it in, I give you an 8 or a 7, and you go, and you grumble a little bit, and I grumble at you as I'm grading it. But it changes the learning perception. So this is a dialogue, a discussion that I don't think has a quick end. I think, as Larita has commented, I think every class you're involved with has a computer component at this point, and it's a lot to do with faculty trying to survive. One of the things that we've found is a compressed calendar that is just chewing people up energy-wise, and so they're trying to find ways of not having to grade homework. And it was my way of surviving this semester, adding an extra class for me, because I am at my limit. Not often I say that, but I think I'm at my limit of what I think I can handle at 180%. It's just there aren't enough hours, and I made the mistake of turning off the alarm last night and woke up at 4:15 instead of 3:15, and so lost a whole hour of grading this morning that I just can't afford to lose. So when you're fine-tuned that tightly, as most of you are, you know the feeling, and that's not where we need to be. But the computer allows us, in some ways, to do more than we'd otherwise do, probably to our mutual disadvantage. So be a little more critical of the computer and a little less to say it's right because it's a computer. Okay, there's a phrase in computer technology called GIGO, G-I-G-O, and it's an acronym that stands for garbage in, garbage out. You put the wrong stuff in, and I don't care how good the computer is, you'll get garbage out. It's just a lot faster than it did without the computer. Other questions in the homework? Anything else? Emily? Now, I gathered from your voicemail that you weren't going to be here. Was that yesterday's voicemail that I got? Well, I just got it this morning. Okay, good. Okay, and you have one from there, okay? Okay, well, why don't you give me a page number, and I can go back center, and we can go to the document cam. And by the way, my appreciation to the publisher. Yesterday they were here at the Student Center, and I said I would really like to have a book that doesn't have all the bloody answers in it. And so he went and got me one.
Oh, cool.
So I have a new book. Well, the one that they send to instructors oftentimes is an instructor's edition that has answers written in that I don't want you to see when we look at the problem. That I keep having to use these 3x5 cards, and I sit there juggling cards back and forth. I get frustrated. You get impatient. Sometimes it works. What page number are we on?
362.
362. So I thought that was a nice, quick response. He went next door and bought one.
Number 37.
362. And this even is a little bit more solid than before. Which number?
Number 37.
37. I was on 363, wrong page.
And
Okay, here's the problem. And notice no answers with it. Isn't that marvelous? I love non-technical solutions. Okay, there's the problem. 2 over 3n squared minus 7 over 9n.
my question is,
Okay, question.
after working through it, how I did end up with 6 minus 7 over 9 and 2.
Wait. You said 6 minus 7?
Yeah.
That's what I thought you said. Okay, let me take this space right behind me because I'm going to challenge you on the number you gave me. Because there's something that didn't happen here. Here's my original problem, and as you listened, I hope you heard, and then you said, I know what you did. And you shouldn't have. What's the LCD? 9 what? 9n squared.
But how's that work?
Okay, but here's your 9n squared, because you had n squared here, and this is 3 squared. So 3 squared, n squared is your LCD. So what do I have to do to this one to get to the LCD?
Oh, that's how you got the n up next to the 7.
Okay, that's what I heard when you said that you had 7, and I thought, aha, you didn't change this fraction to where it was 9n squared. So this one you had to multiply by 3, correct? So we have a 3 here. So that's where the 6 came from. But what happened is you didn't have the 9n squared for this one, even though you said you had it as an LCD.
I have that, but I couldn't figure out how the n got next to my 7.
Make sense now?
Yeah, thank you.
And then what's interesting you can look at something like this for a half hour, and you don't see it. Somebody else looks at it for 15 seconds and says, oh, you didn't do this. And you say, oh, yeah. And it's suddenly clarity. But why, when you look at it for that half hour and you pound your head against the wall, you get more and more angry with yourself? Doesn't work. I have no idea. Does that answer the question for you? 6 hours later? Well, you hope. Now, here's a point. And I talked with somebody else this morning who said they found out their solution to some of the difficulties they were having was to do the homework during the day and not wait until 11 o'clock at night when the kids are asleep, the house is quiet. Because at 11 o'clock at night, if you are as wiped out as I am at that point, your head is just not cooperating. I mean, the spirit may be there, you may be determined, and you can't make heads or tails out of anything. 3 o'clock in the afternoon, maybe 1 o'clock in the afternoon, clarity would be there. So, my argument is, when you can, start your homework early. Even if you don't get the problem, then your head has a couple hours to just sit there with, you don't know what's happening, but your head subconsciously is doing things, and maybe at dinner hour, suddenly you see the solution. For me, it's doing something that is non-thought provoking. Riding a bike for 10 miles, just pedaling, amazes me how it clears up your head and suddenly things start popping into your head and you make sense out of it. Now, Sarah does it. She'll do something with the house. She'll say, okay, I'm going to go do this, and she'll end up vacuuming a room. Same argument, just so you're doing something that you're not thinking about the problem you're doing. And then you come back and suddenly clarity. That's where the people who say at 3 a.m. in the morning, gee, I woke up and it suddenly had the answer. Okay, then you write it down, because if you don't, by 7 a.m., all you'll remember is you had the answer at 3 a.m., but you don't remember what it is. Richie, comment.
Yeah, I don't mean to slow you down, but I wasn't here yesterday, so I don't know how you can find that.
The LCD? Okay, I used the prime factoring we did before. So if I look at these two denominators, I had a 3n squared and a 9n. Same game we played before, write everything in primes. So that's 3 to the first, n to the second. This is 3 to the second, n to the first. So you write down the primes and the numbers, the prime numbers and the letters you had. So the primes and the letters were 3 and n. So this is for the LCD. That's all I had, right? 3's and n's. What was your highest exponent? Since this was 3 squared, and this was 3 to the first, your highest exponent is 2. You had n to the first, and n to the second, your highest exponent is 2. Same thing we did before. 3 squared, n squared, that gives us 9 n squared. The difference is I now have letters involved and not just numbers. And perhaps as we do some more problems, as I answer questions, maybe we can do more with that. So give me a moment, and hopefully I can come back and try to answer your question a little bit more thoroughly. But before we let this set go, are we okay? No. Okay, Ernie, I need then possibly to switch cameras on number 2, but let's find out what James is going to ask. Is it a computer problem? Okay, and it's... Okay, let me go back center here for a moment. Like 75, you say? 76, one of the word problems? Okay, let's come back to this, what we call a pie chart as we come. Okay, and I chose this because I wanted something that was statistics. Since you've seen so much of stat when you were in here in Math 10 and we were doing the stat presentation every morning, and we did pie charts. And so the idea is the pie charts, and by the way, pie charts don't involve fractions. That's one thing that bothers me. A pie chart would have percents. So you wouldn't see a 3/5, you'd see a 60%. And you wouldn't see a 1/8, you'd see 12.5%. And you wouldn't see a 1/6, you'd see 16 2/3%. But the argument is this pie should be 100%. Now, I can tell I'm hungry because I'm seeing apple pie and slices being pulled out, blueberry pie and apple pie, and I don't know what green is, but Anyway, rhubarb. Okay. Well, rhubarb's sort of red after it's right. But we want this portion, right, in green?
Yeah.
So we need to know what is the sum of all these and then subtract it from 1. So that would be the intent. So as I leave that up on, can we use this one as an illustration, or do you want to go with the one you had? It's okay either way? So as I look at this, what I'm really saying as a problem is I'm saying I want to take 1 minus, and then in parentheses, and let me write down these fractions. A 1/6, and I'm going to add to that a 3/5, and I'm going to add to that a 1/8. Do I have it now? And that's the green portion. So what do I need? Common denominator, correct? So I factor this into 2 to the first, 3 to the first. This is 5 to the first, and this is 2 to the third. True? So what are the primes I have? 2s, 3s, and 5s. So 2 times a 3 times a 5, and I'm using x's here for multiplication where we've been using dots more often. But my highest exponent on the 2 was a 3, and the highest exponent on the 3 itself is 1. And the highest in the 5 is 1. So my LCD is the product of this. So this is an 8, times 5 is 40, times 3 is 120. Now I don't know if there's a faster way of doing this, but this would be my first reaction rather than going to decimals. Kim? Question?
Why is the 1 there? The 1 minus before the 14?
Well, I have 100% or 1 whole pie.
Oh,
And I'm taking those other slices out. So everybody else is eaten, it's Thanksgiving, and I get the 1 piece of green pie that's left.
okay. So if there was 2, you'd put a 2 there?
Well, but there'll never be 2 pies. You just have 1 pie. You can't be going to Marie Callender's and buying 2 of these. You only get 1 of them at a time. Okay. So what am I going to do to this? Find new fractions. So I can take my 1/6 and my 3/5 and my 1/8 and add them together. So I'm just going to do this vertically. That's 120. And then I had 3/5 over 120. And I have 1/8 over 120. And I remind you, of course, that we've done this before a lot of times. And how do you go ahead and decide what goes in the numerator? One is to just divide 6 into 120. It goes 20 times. So you multiply. So I have 20 here. I divide 5 into here. Or I could come back and say, if I have a 5, what am I missing? 2 to the third times 3, that's 24. So I can just do a Sesame Street approach to it. That's 72. Then I'm down to the 8, but that was 2 to the third. There's a 15 left, so that was a faster way than dividing. And I've encouraged you to do that. Now, the intermediate step, since I want to add these, is to take the 20, the 72, the 15, and put it over the 120. Okay, and that comes out as what? Okay, 20 and 15 is 35. Add that, and you get 107. Do we agree? 107 over 120. So what does that leave when I take 1 minus that? 13 over 120? No, I think you are at this point thinking of the pie that you'd like to eat for lunch.
Yes.
Okay, but we have 13 over 120. And it does not reduce. 1 minus 107 over 120. And this is 1 over 1, which is 120 over 120. Minus 107 over 120, which is 120 minus 107 over 120. Thank you. We got it? Now, a very contrived problem. And I have mixed feelings about contrived problems, but I understand the reason the author is going to this. And in all fairness, I made the comment to the publishing rep yesterday that I'm delighted with the book. I really like what this author's done, and it's in the same spirit of what I would do. From a practical point of view, you are not going to see a pie chart like this and have to do something like that. You'll see it as decimals or as percents. But it's an interesting problem, and I get you to see a pie chart, which is one of two graphical presentations for data, what we call non-numerical data, called categorical data, where we're counting maybe number of Chevys, a number of Fords, a number of Plymouths, and that kind of thing, in categories. The other one is a bar chart. And the pie chart is ubiquitous in the area of business. You see it everywhere. And as you look at the economy and the comparisons that are being done, you see a lot of bar charts, a lot of pie charts, and a lot of broken line graphs where they're trying to show you just how bad things are, like you didn't know. But anyway, this is part of statistics, so does that answer your question, James? Any other questions from last night's homework? And that's a lot of time to spend on what we got out of that. The pie better be good. And by the way, do you know that we're coming up to Pi Day? 3/14. March 14th is Pi Day. It's celebrated in the scientific community. No. It's a Saturday. I'm giving a test. However, if you look at today's paper, there's a marvelous little presentation on Pi Day where they give pi that looks like 100 digits or so. So if you want to know what pi looks like with 100 digits, remember it's 3.14159, and I say garbage to come? What kind of pie do you think I'm talking about with 314.9? Sandra, you are not awake. I am talking about pi, P-I.
I thought you were talking about like a pie that you eat.
Yeah, like National Pie Day.
Yeah, that's what I thought.
National Pie Day. Everybody goes out and gets a pumpkin pie, right? Okay, I'm sorry I did not communicate better with you. But 314 refers to the irrational number that is used for geometry, like in pi r squared. Okay, enough of that. That did not go quite like I wanted. New section. More fun. Okay, 5-7. Order of operations. What are the order of operations again? Please excuse my dear Aunt Sally. Parentheses. Exponents. Now, radicals get thrown in there with our book, so we also have radicals. But my dear Aunt Sally refers to multiplication, division, subtraction, and addition in order given. So, with all that done, we see things like this at the very beginning on page 365. Remember, we are using the dot for multiplication at this point. And we don't have to worry about that for decimals because we are acting like they don't exist. But the minute we throw a decimal into this, then we're in deep trouble again. So we'll have to completely give parentheses. Now, to say parentheses first, you don't do anything there. That parentheses is okay. But what must you do first? The multiplication. And so this is a trap, pure and simple. You're supposed to avoid a knee-jerk canceling out that 5 and screwing it up. So what do you do first? Improper fraction. And so you change that 2 4/5 as is done here as I slide it down to 14/5. Then you can cancel. You can see the canceling here without me putting it in the board, done just as we do it in a Math 10. That simplifies and gives you, coming off there for just a moment, if you will, Ernie, so I can relocate the camera. You get to this point. The only thing that is different here that I would encourage is the intermediate step that does not follow. I would want 9 minus 28 as an intermediate step, and instead the author goes to negative 19 right out of the gate. Pardon now? You could rewrite that as 1, negative 1 and 7/12. I agree. And that is done in the presentation. If I just slide down, there it is as a mixed number. Nothing new, correct? We've been there before as we come off that. So that I'm hoping you say, okay, we've done it, we've seen it. I can even get nonsense like this, and I'm not sure I'd ever want to do a problem like this, but you could. Now, something is being presented here as a new idea, mean and median. So let me talk about it. This is called a mean at the top, and it's talked about the middle of numbers. So let's leave that there for a moment. I'm going on the side. Be careful you don't get trapped. Back to statistics. Here's a set of numbers. I'm going to put them in order. A 10, a 7, a 6, and a 5. Test grades. Somebody got 10 in a quiz, somebody got 7, another got a 6 and a 5. And I want the average. You'd add the 4 up and divide by 4. No, that's the mean. So if I add all these up, take 10 plus 7 plus 6 plus 5 and divide by how many, that's the same way you get your test average. This is your quiz average. This is given the name a mean. Okay, that's the mean of that set of data. Medians are the middle of the data. So I have 4 numbers written in a sort, and these 2 are in the middle. So I average these 2 numbers to get what's called the median. So the median in this case is to take the 6 and the 7, add them together, and divide by 2, which is going to give you 6.5. Now, the mean and the median, you would love to have the same number, but typically it's not. Here we have 17, 23, 28. So 28 over 4 is a 7. And this mean is different than the median. Often the case. The symbol, just for information, is an X bar. The symbol here is X with a tilde over it. Okay, so an X tilde and an X bar. Back to the book now. In the book, the thing that makes this interesting is your data is what? With fractions. And again, just a contrived problem, because if you're going to do statistics, as we come off there, you're going to have decimals. I've been teaching stat for a long time, and I have never had to find a mean of data in this form. However, we're working with fractions, so in the positive way, you're learning about stat. And by the way, that is referred to as a numerical descriptive analysis. The pie chart was a graphical statistical analysis. It was a graphical description. This is a numerical description. And you're picking up some stat along the way, and I like that. Now, this ag student measured things with inches and then wanted to average it. 6 measurements. Now, my response to this student, had they come to me and said, okay, will you change everything to a decimal and then we'll talk. Instead, we're supposed to do what? Rearrange everything, and after it's rearranged, then find the median, or as we come off there for a moment, and there's no way in the world I would take time to do what's done here to illustrate this for you, in which we are finding a common denominator of 8 for everything, getting all that added up, and then divide by 6. Never in your life would you see me do that.
They didn't arrange it either.
Well, they didn't arrange it there, but down here they did. You don't have to arrange for the mean. Here is the arrangement for the median. And then, because if you have 6 pieces of data, it's the middle 2. That's where you were forced to average these two. By the way, if you have an odd amount of data, the median is one of your values. It'll be the one in the middle. So if I had, instead of 6, 7 pieces of data, the median would be one of the numbers. Okay? The median, by the way, is used more often than the mean in the business community because the median is not influenced by very high or very low values. So if you have housing 18 months ago, 24 months ago, before the bubble burst, and you had a house at $1 million and everything else was at $500,000 or lower, if you calculate the mean, that $1 million house is going to inflate the average. But if you take the median, that $1 million house does not influence it. So when you hear data on housing and they say the average cost of a house in California, they usually are talking about the median, not the mean. That eliminates the very expensive homes from influencing the number. And by the way, what is the average price of a house now as compared to about 2 years ago? About half, right? Where we might have been up at, say, 400, we're down at 200, which is called being upside down in your house for many people. If you owed $300,000 and it's worth $200, you're now upside down. And that means if you have to sell it, you're screwed because you have $100,000 you need to pay to the bank just to get out from the loan. So you're either terribly wealthy or you just keep your house. Don't sell. Or you walk away. Okay. And I did not advise that. Now, page 370. This is where things get a little bit more interesting. Now, that usually means harder. I understand that. Here is a polynomial. Okay, it is what degree? Third degree, highest exponent. What do we have to do to simplify it?
Combine like terms.
Combine like terms, right? I didn't hear Sandra. What did you say? Nothing. Okay, you're going to combine like terms, right? So I need to do that 1/4 and that 1/6 as coefficients of a cubed. Agreed? And then I have to take the negative 3/5 and the 1/2 and simplify that for the a. Now, I don't particularly concur with the solution presented there. So let me do a little bit more of what I would have in mind. Let me write this out. And again, this is just to keep you working with fractions. And remember, fractions are nice. You love fractions. Just keep saying that. I love fractions. Like I love springtime. Paris in the springtime. You love fractions in Modesto. 1/6 a cubed. And then I have a plus 1/2 a. Now what I would like to do is to say, well, I have a cubed times 1/4 plus 1/6 using the distributive property. I prefer that. Then plus a times 1/2 minus 3/5. That would be my preference. And then work the parentheses separately. There's no need to really carry through common denominators for everything. So what's your common denominator for a 4 and a 6? The 12, agreed? So I have a cubed times 3 plus 2 over 12. And then what's my common denominator for a 1/2 and a 5th? They're relatively prime, so I can multiply them this time and have a 10. So I have a. This will be over 10. And notice I'm leaving some steps out here. But I like that better. And it's more in terms of what we're doing with algebra. Now again, this was 5 over 10. This is 6 over 10. Hence 5 minus 6 over 10. I'm doing an intermediate step as I do that. Sandra, your look says...
I just don't see where you got the 5 and 6.
Okay, this is supposed to be a 10 as a common denominator. How would I get that as a common denominator? Multiply top and bottom by 5, 5 over 10? Okay. Now, going back, I have a cubed, and I have 5 over 12, correct? So we would typically say 5a cubed over 12, And then here, what do I have? Well, I have a negative 1 over 10. So I would say negative a over 10 and be done. And I can't reduce anything. Now you could trade off the plus and negative for just saying you have a difference of 5a cubed over 12 minus a over 10. Now, the advantage to what the author does is I can find a common denominator for everything now. And what is the common denominator at 10 and 12? I like the 60 better than I do the 50. I can't take 12 into 50 and make it even, but the 60 I can. So I could say that's over 60, and I need to multiply by 5, top and bottom here, so you get 25a cubed. And here, for the 60, I have a negative 6a, and my guess is that's the solution in the book. Your choice. Again, it's rather contrived. Let me tell you what I would do in this problem, because you are not going to see an expression like this mess and leave it that way. And you aren't going to go through everything I did here. Never. But we're contriving things to give you practice, bless you. Let's slide over, Ernie. A little bit. I need there. Enough. Now, this is typically going to be equal to something. And the first thing I'll do is multiply everything by 60. I believe that's necessary. Yes. By 60 to get rid of the denominators. One more time. This will be equal to something as an equation. And I don't want to deal with those denominators. Fill in the blank denominators. I don't want to deal with them. I get rid of them legally. Multiply both sides of the equation by the LCD and they're gone. So you aren't going to do this. But it's good practice to discipline yourself to do this, because you should be able to. So that sense of balance, what is it you're going to be expected to do, and what the advantage, educationally speaking, that's what we mean by pedagogical. What is the educational advantage of carrying this through? You get more comfortable with fractions, and you tend to avoid them. Fractions are your friends. Leaving that where it is. I'm curious to see what the author did.
I love fractions.
You love fractions, and you are as insincere as can be. Okay, I owe the author an apology, because what is the answer? 5/12a cubed minus 1/10a, where I wrote minus a over 10. Okay? But I'd never do that. Multiplication. Now, just as we come down here, you know the drill. You can see it here written very nicely in the solution, exactly as I do it. Most of the time, the author and I are on the same page, and I'm very comfortable with that. Add the exponents, show the cancellation, and get your answer. That's exactly where we've been. Okay, so coming off there. When you multiply two monomials together, and I have m to the first times m to the third, you add the exponents. This is the problem on a test that you did not do well. Okay? Where you're supposed to FOIL, right? And you're supposed to multiply the 3/4 x times the 1/2 x and get an x squared. My emphasis there is because you didn't. And then you multiply 5 times 8. And James, you would get 40 and not 3. Not that you would do something different than that with how many hours of sleep was it that night?
Negative 41.
1 hour of sleep? Okay, I was reminded that as we come off there, the person who did our telecast the last hour had come back from Michigan, and she's had 1 hour of sleep in 48 hours. And I thought of you, James, with the same thing. She was doing the telecast, you were doing a test, and strange things happen. So at any rate, as we come back, just a reminder, here's the nice presentation of FOIL. I don't want to belabor it. Just be cautious. You can see the process there, and my goodness, Kim, I think this is one that you had a moment of meltdown also on the test, yes, and Natalie and James, and it was ubiquitous. Everybody had problems with this. Okay, so well, it is, but you're supposed to be able to do it, so we'll leave it at that. You have something beyond that I want to look at. Just a reminder, if you look at these two problems, the 51st problem, the author has been extremely kind to you, comparatively speaking, yes? You could do that in your head sitting there, I would hope, but maybe not. What do you have? Somebody want to give me the answer? An x squared, first term, last term? There you did it. You want to multiply, not add. 1/2 and 1/4 added is 3/4, but you're supposed to multiply 1/8. So it's an x squared, then you have a negative 1/8 at the end. You have a negative 1/2 x and a positive 1/4 x, so you have negative 1/4 x. Michael, questions? One last question.
Question on the example 11. Do you do fractions before you do multiplications?
Okay, there's a question about fractions and such, and I'm going to have to answer that off camera because I'm down to my minute and a half. So, Ernie, as you finish out.